Business Analytics.
In the headlines:
Data, information, and knowledge. Analyst's role in a business analytics model. Requirements the analyst must have. Required competencies for analysts. Analytical methods, information domains. How select the analytical methods. The three imperatives. Descriptive statistical methods, list and reports. Hypothesis-driven method. Explorative methods. Business requirement. News.
Good morning, BA students! I am your anchor, Catherine Joy Agredo. Today, I will be discussing about the data, information, and knowledge. Second, analyst's role in the business analytics model. The third one is requirements the analyst must have. And the last is required competencies for analysts.
In business, we tend to differentiate more concretely between data, information, and knowledge. So let's start with data. Data is the lowest form and refers to unstructured facts and figures which lack any kind of organization. The next level is information. Information refers to data that has been organized, condensed, contextualized, and so on. Now, the data has a direction and a purpose. Like for example, data is generated when a product is manufactured and marketed. There were lots of numbers and facts regarding cost, pricing, income, and market research. This data become now an information. On the other hand, knowledge represents a deeper level of understanding and interpreting, and know-how it is very much based on experience and rooted in context. Example of knowledge is how to fix a machine, how to organize an assignment or project, and how to sell your product. You also notice the knowledge can come in substantially varying degrees. For instance, you may have someone who's good at marketing, or may have some who's a true marketing whiz. You may have a newly graduated IT support worker, and you could have a highly experienced who the years of work provide invaluable insight and intuition into solving a problem. Illustration says that the analysts bridge the two environments, which are technically oriented environment and a business-oriented environment. So, the data has been provided by the data warehouse, will understand and analyze by the analyst. The analyst will provide information and knowledge which will be receiving by the firm or business. After receiving this information and knowledge, the business have time to think of what strategies they will apply or a solution for their either financial or operational issues. Always remember that we need to ensure that we've got a process of an information strategy that ensures coordination and future planning between business and the data warehouse. There are three clear requirements of our analyst. One is business competencies. Second is method competencies. And last is data competencies. In business competencies, the analyst must understand the business process he or she is supporting and how the delivered information or the delivered knowledge can make a value-adding difference at a strategic level. Secondly, the analyst must also be able to independently optimize the information or the knowledge in such a way that user is given the best possible decision support. And last, the analyst needs to be capable of having a continual dialogue with the business, as well as of detecting and creating synergies across functions. In method competencies, the analyst might also be able to visualize the information in such a way that the user gets an overview of all the data material in the first place. Second, the analyst must be able to deliver more than information in a model and take part in the analysis of this information to ensure that the relevant knowledge is obtained. In data competencies, the final requirement that we must make of analysts is that they have a basic understanding of how to retrieve and process data. This is all about how to structure processes, because just as analysts have to sometimes draw on support from the business in connection with the creation of information and knowledge, they must also be able to draw directly on data warehouse competencies. Take note that analysts need to master 3 professional competencies to be successful: the business competencies, the method competencies, and the data competencies. Lastly, an analyst derives only a fraction of the knowledge that is potential if he or she fails to use the correct analytical methodology. Analysts can therefore generate considerable loss in value if they are the weak link in the process.
Thank you, Catherine, for that report. To continue, I will going to discuss about the analytical methods, the information domain. Next is how to select analytical methods. Next is descriptive methods, list and reports. Under the descriptive method list and report, we have ad hoc, manually updated reports, automated reports on demand, automated reports event-driven. Lastly, we have report in general. Analytical methods, the information domains. So, in the previous section, we discussed the analyst role in the overall BA value chain, which stretches from collecting data in the technical part of the organization to delivering information or knowledge to the business-oriented part of the organization. So, we also outlined some requirements of analytical function, one of which was that it must function as a bridge between the technical sides and the business sides of the organization, and thereby form a value chain or a value creating process. Another requirement is that the analytical function must possess methodical competencies to prevent loss of information. So when we say loss of information, it occurs when the accessible data in the data warehouse provided is retrieved and analyzed in an optimum way, has a potential of delivering business support of a certain quality but cannot because this quality is compromised. Reason for this lack might be the simple failure to collect the right information, which might in turn be due to lack of knowledge about the data or lack of understanding of how to retrieve it. But errors might also be traced to the analyst of not having the necessary toolkit in terms of methodology. For example, the analyst derives only a fraction of the knowledge that is potentially there. If we therefore imagine that we have a number of analysts who are able to extract only 50% rather of the potential knowledge in the data warehouse, in terms of business requirements, we have a corresponding loss from our data warehouse investment. So when we made the decision to invest in the data warehouse based on our business case, we naturally assumed that we would obtain something close to the maximum knowledge. Instead, we end up getting only half the return on our investment. So that means that the data warehouse investment in the business case should not have been twice big. If we look at the business case from this perspective, it might not have been a profitable decision to acquire a data warehouse. which means the investment should not have been made. Analysts can therefore generate considerable loss in value if they are the weak link in the process. Okay, let's proceed to how to select the analytical method. So, in chapter 3, Dindo discussed the strategy mapping process, right? So now, we will pick up this thread. I am going to discuss the information mapping process. So, let's see the exhibit 4.2. These are the 3 imperatives in connection with choice of methods and information mapping. We will start with some specific information requirements and proceed to identify which specific analytical techniques will deliver the required knowledge or the desired information. The aim is to present a model that can be used in a dialogue between management, who wants information, and the analyst who must deliver it. In the introduction to this chapter, we said that we would be delivering a menu. What we want to deliver here too are some key questions to ensure that the dialogue between analyst and the recipient provide an overview of how this menu is designed to facilitate the right information being ordered. More specifically, this means that we divide a potential BA deliveries into 4 information types. So, let's see the exhibit 4.2. They deliver the question that will help clarify which information types are the most relevant and go through the 4 information types one by one. Concentrate on how types that is relevant. So in terms of perspective, we start with a business perspective and finished with an analytical perspective. So, example, by requesting information about which customers will be leaving us in the next month, and finish perhaps with the answer that the neural network will be a good candidate in terms of selecting a method of delivering results. The business-oriented reader who wants to understand more about the scalability levels, say, can log on the basupport.com, where we have included an interactive statistic book along with the number of examples and case studies, as well as the contact details for the author. Next is the 3 imperatives. We obviously not suggesting that the analyst read through this whole text every time he or she needs to determine which methods to use to deliver which information or which knowledge. The idea is that the analyst has read the text beforehand and is able to implicitly draw from it and his or her dialogue with the business. So let's see the exhibit 4.2 once again, where the question number 1 determine with the process owner whether the quantitative analytical competencies or the data manager and the report developer competencies are required. Okay, for example, the user wants to find the answer to is there is a correlation between how much of a raise we give to employees and the risk of employees leaving the company within 1 year. So in this case, the data manager or the report developer will be able to deliver only the table or report that shows employees in groups according to the size of their pay increase and what percentage within each group have changed job. So the analyst with a statistical solution will be able to say, yes, you can say that, yes, we can say with 99% certainty that there is a correlation. The analyst is therefore creating not only information but also a knowledge. Okay, the last question number 3, determine whether the data-driven method has the objective of examining the correlation between one given dependent variables and a large number of other variables, or whether the objective is to identify different kinds of structures in data. We begin by describing situation where we have a target variable. We would want to describe this variable via model. We could be an insurance company that has collected data via test samples about which claims are fraudulent and which are true. Based on this information, we can train a model to understand when we have a fraudulent claim and when we don't. From that point forward, the model can systemically help us identify and follow up on the past as well as the future cases that are suspicious. Therefore, we have a target variable, has it fraudulent or not, and a number of other variables that we can use to build a model. These variables might describe factors such as which types of damages, under which circumstances, which types of people report them, whether three have been frequent claims, and so on. A target variable might also be the right price of the house. If we are a mortgage lender, we can make a model based on historical prices that illustrate the correlation between the price of the house and the factors such as location, the size, when it was built, and so on and so forth. This means we can ask our customers about these factors and calculate the value of the house and the derived security it constitutes for us lenders, thus saving us sending a person out to evaluate it. Another target variable might be the customer satisfaction. If we send out a questionnaire to a large number of customers and then divide the customers into groups according to satisfaction level, we can make a model that combines satisfaction scores with our internal data warehouse information about the customers. We can then train the model to understand the correlation, and based on the model, we can score all the customers who did not complete the questionnaire. Then, we end up with an estimated satisfaction score, which we can use as a good substitute. As opposed to data mining techniques that build on a target variables, we are now see a large number of analytical techniques that look for a pattern in the data. The techniques that we have included here are the techniques for data reduction. Conclude the following discussion of the three imperatives that must be considered in order to identify which information domain to use in connection with the information strategy. We will now go through the general methods we've chosen to include.
Thank you, Joanne. For now, we are in the last three topics of this chapter: the hypothesis-driven methods, the explorative methods, and the business requirement.
Hypothesis-driven methods. When working with hypothesis-driven methods, we use statistical tests to examine the relationship between some variables. There is a general requirement that we do not just hold all sorts of variables up against each other, but that we must have some initial idea of a relationship. This doesn't change the fact, of course, that every 20th time a test is performed between two variables that had nothing to do with each other, a statistically significant relationship will be found anyway, but it does not remove some of the incorrect knowledge we would otherwise be generating. In BA context, this means that if we want knowledge about our customer, we first have to go through a process of identifying which variables we want to include in the analysis, as well as which relationships between the variables it makes sense to test. This is exemplified in Exhibit 4.4, where statistics and VA contexts are typically about identifying the relevant data and testing for relevant correlations. Based on the identified significant relationships between the variables, we can make an overall description as a conclusion on our analysis. Tests with several input variables. There are tests that can handle several input variables at a time. The advantage of these tests is that they can reveal any synergies between the inputs variables. This is relevant if, for instance, a company is contemplating changing its pricing of a product and combining this change with a sales campaign. Both these steps are likely to have a positive effect on taking the two initiatives at the same time. It is not enough. Therefore, to carry out two steps,
one that shows the correlation between price and sales of a product, and one that shows campaign launch and sales on the same product. In fact, we need to investigate a third dimension, which just to choose depends on the dependent variable. The dependent variable is the variable that we want to learn something about, which in the previous example is sales. In the field of statistics, we distinguish strongly between the scaling of the dependent variable, as this determines which method to use. If our knowledge about the correlation between the price of a house on the other hand, and everything that determines this price on the other, how old it is, its last renovation, number of square meters, size of overall property, insulation, and the like. The most commonly used method in this context is called linear regression analysis, and it describes the correlation between the interval variable and a number of input variables. Techniques which we look for correlation over time would also typically in this category. Forecasting techniques are based on looking at the correlation between, say, sales over time and a large number of input variables such as price level, our own and other campaigns, product introductions, seasons, and so on. Based on this correlation, we can conclude which factors determine sales over time, whether there are any synergies between these factors, and how much of delay there is before they affect. If we are running a TV commercial, when do we see its effect on sales and how long does its effect last? If we have this information, we can subsequently begin to plan our campaigns in such a way that we achieve maximum effect per invested marketing dollar. Forecasting is thus used for two things. Number one is to create projections of trends, and number two is to learn from historical correlation. Forecasting methods are therefore extremely valuable tools in terms of optimizing processes, where we want to know based on KPIs how we can best optimize our performance. If we want to create profiles, or which means that there are only two outcomes, example yes or no, and example new customer profile or old customer profile, using BA information, this might be a case of wanting a profile on the new customer we get in relation to our old ones, or an analysis of which employee gave notice in last year. What we want is to disclose which input variables might contribute to describe the difference between Group A and Group B, where Group A and B respectively are the dependent variable. If we take the example of employees leaving the business in the last year, there might be an information such as age, gender, seniority, absence due to illness, and so forth that might describe the difference between the two groups. In this context, the method is typically used is a binary regression analysis. In some cases, we want to explain how the variables rank because we want to know more about satisfaction scores, where the satisfaction scores were typically they called something like very unhappy, happy, neutral, unhappy, or very unhappy. A rank variable is therefore characterized by a given number of optional answers that are ranked, but where we cannot average them. Although many people code the rank variables from the 1 to 5, is statistically and methodically wrong to do so. Finally, if we want to understand something about a group, we would use a nominal dependent variable. Maybe we have some regional differences of certain groups of employees that we want to understand better. We can't just rank regions and say that Denmark ranks better than Norway, and then Sweden is third. One analysis could focus on the different characteristics of our customers in the Norwegian, Danish, and Swedish markets, where our input variables could be gender, age, education, and purchasing history. In this case, we would like to typically use a generalized linear model or the GLM analysis. Data mining reveals correlations and patterns in data by means of predictive techniques. These correlations and patterns are critical to decision making because they disclose areas of process improvements. By using data mining, the organization can, for instance, increase the profitability of its interaction with customers. Patterns that are found using data mining technology help the organization make better decisions. Data mining is a data-driven process. A data mining project often takes several weeks to carry out, partly because we are often thinking about large volumes of data as input for the models. This is true even though the development in computer power has shortened this process considerably, partly because we probably want to automate the process so that it can take labor form in a matter of hours next time. To perform this task, it is essential to specialize data mining software that is managed by analysts, rather than conventional data warehouse people. We also recommend that companies choose a software vendor who offers courses in the use of their software, and course fees have a quick return if data mining is being performed for the first time. Pivot 4.5 shows the data mining process in 3 steps. First is creating a number of models, second selecting the best model, and third is using the selected model. Data mining algorithms. In the field of statistics, a precedent has been established for choosing which specific statistical methods or algorithms to use based on the data we are holding in one hand and the conclusion we would like to be holding in another. In data mining, there is a tendency to prefer the model that will render the best results or unknown data set. The purpose of data mining with a target variable will always be to explain this target variable. It is comparable to a statistical test where we have a dependent variable and many explanatory ones. The only difference is terminology, where data mining uses the terms target variable and input variables. As with statistics, our target variables and tasks that we are trying to explain and predict might be an estimate, a profile, a ranking, or a grouping. There are 2 most common techniques or neural networks and decision trees. Neural networks are characterized as being fast to work with. They do not have a significant weakness, however, of being practically impossible to interpret and communicate because of their high level complexity. On the other hand, decision trees are easier to interpret and have the added advantage of being interactive, giving the analyst the scope for concept adaptation of the model according to what he or she thinks will improve the results. The additional one algorithms is the OLAP, or the Online Analytical Process Cubes, where are the pivot tables, where the analyst can continue to drill deeper and deeper into the required dimensions. The analyst constantly receives the decision support in the form of statistical information about the significant or incidental nature of the discovered differences. Explorative methods. In BA, we typically see 4 types of explorative analysis. These are the methods for data reduction, cluster analysis, cross-model models, and upsell models. In connection with explorative models, we leave it to the algorithms to discover tendencies in data material. The methods are therefore data-driven, but there are no target variables that we want to model. Consequently, there is no way to conduct quality assurance testing on our models by testing them on unknown data sets. The quality assurance typically consists of analysts evaluating whether the identified patterns make sense, which is the reverse of what we know from statistics and where the theory precedes the test. Another way of assuring the quality of model is, for example, to let the same algorithm make a model on another and similar data set, and if all the algorithm comes up with the same model, we can presume that it is not a coincidence in the data given material in combination with algorithm that gives the result. Alternatively, we could let 2 different algorithms analyze a data set, and if they produce comparable sections, we could presume that if the result of same underlying patterns in data and not a coincidence in the interaction between the individual algorithm and the data set. The first Explorative data reduction is used in connection with analysis of questionnaire information where we've got a large number of questions that are usually disclosing information about a smaller number of factors. Instead of questionnaire with say 20 questions about all kinds of things, we can identify how many dimensions are of interest of our customer and then ask about only these. We could therefore move from measuring customer satisfaction using 20 variables to measuring only the 5 variables that most precisely express our customers' needs. These 5 new variables will also have the advantage of having no internal correlation. This is ideal input for a subsequent cluster analysis, where many variables sharing the same information affect the clustering model in the way that we do not want. Data reduction is typically used when there are many variables that each contain little information that is relevant in terms of what we need. Using this method, we can try to condense the information into a smaller number of variables in the hope that the new variables now contain a concentrate of relevant information and that this can make a positive difference. The most popular method for the data reduction is the principal component analysis, or the PCA, which also called the explorative factor analysis. The correspondence analysis is also quite commonly used. The second explorative method is the cluster analysis. The other type instead of working with a very large number of individual customers, we can produce an easy-to-see number of segments of clusters or for observations. There are numerous methods but are basically focused on algorithms to combine observations that are similar. In statistics, cluster analysis are typically used to investigate whether there are any natural groupings in data, in which case analysis can be performed on separate clusters, while data mining typically uses the identified cluster if this improves predictability in the model in which they are to be included. Finally, the purpose of the analysis might be segmentation per se, as this will give us an indication of how much we can make some natural divisions of segments based on information about the customer's response and consumption. The third explorative method is the cross-sell models. Cross-sell models are also known as a basket analysis models. This model will show which products people typically buy together. For instance, if we find that people who buy red wine frequently buy cheese and crackers too, it makes sense to place these products next to each other in the store. This type of model is only used in connection with combined offers. They're used too when a company places related pieces of information next to each other on its website, so that if customer wants to look at the cameras, he or she will find some offers on electric storage media too. Last but not the least is the upsell models. Upsell models are used when a company wants to create more sales per customer by giving the individual customer the right offer at the right time. These models are based on the notion that a kind of consumption cycle exists. A time perspective has been added here. We are not looking at what's in the shopping basket once. Instead, we are looking at the contents of the shopping basket over time. Upselling is also a strategy to sell a more expensive or newer version of a product the customer already has, or to have an extra features or add-ons to that product. Imagine an analyst or controller from a BA department who sit at a desk looking accolade you from a business-oriented function in the eye. The business user asks, "So what can you do for me?" There are plenty of good answers to this excellent question, as we shall see later in this chapter. One point that is crucial for the analyst to make, however, is you can deliver business requirements. But what are business requirements? Business requirements is a kind of interpreting and communicating task that is a substantial part of an analyst toolkit. Furthermore, it's a shell product. In most large consultancy firms, the requirement for analysts is to be able to understand and translate the business users' thoughts and needs into something that can be answered through analyst or data manager of report developer competencies. The purpose is to deliver something that can be used by a business to improve processes and that corresponds with the business strategy as well. Producing business requirements requires a sound knowledge of business issues and processes, as well as insight into the company's data warehouse and other IT infrastructures. A good point of departure for the delivery of business requirements is a thorough interview in which the business user is interviewed by the analyst from the BA department. Business requirements can be built in many ways. In this book, we use the three-tier structure, which includes the definition of the overall problem, the definition of delivery, and the definition of content. First, we will gonna tackle the definition of overall problem. Based on this definition, the analyst must be able to place the specific task in broader context and thereby prioritize it in relation to other tasks. Consequently, the commissioner of the task must be able to explain for which business processes the given task will be adding value. If the task is to be prioritized based on a business case, alternatively, the commissioner must relate the task to a strategic initiative. Otherwise, the analyst must be extremely careful in taking on the task because it is not adding value and not related to the business strategy. He or she must question the justification of the task. Definition of delivery. The requesting party or the recipient must specify in which media the analysis must be delivered. It is in HTML, PDF, Excel, PowerPoint, Word, or others, and whether the delivery must include an explanation of the result or whether these are self-explanatory. Deliveries that include automated processes such as on-demand reports or continuous lists of which they are built might be placed out. Errors are inevitable over time, but if effective communication is in, damage to business procedures can be prevented. The question is not whether an incorrect report will be delivered at the same stage or not, because that is not to be expected. The question is how efficiently we deal with the situation when it arises. Other question to clarify about delivery is time of delivery on demand, or under which circumstances we update, event-driven, and whether to notify users when updating. Lastly is the definition of content. In connection with report solutions, the content part of BA project is very concrete since it is about designing the layout as well as defining the data foundation. As mentioned in the section about on-demand reports, this type of report is not just a static document but a dynamic data domain. It could be sales figures that we want to break down into a number of dimensions such as by salespersons, department, area, or product type. Often users experience problems grasping this new functionality. However, we have to remember to train users in how to work with the dynamic reporting tool too. Data quality is a subject that needs discussing also, since our data warehouse contains imprecise or incorrect information which we have chosen to live with for various reasons. What is the acceptable level of accuracy? Can we live with a margin of error of 5% between the daily reporting and the monthly figures from the finance department? In this case, where we don't have the desired information quality in our data warehouse, this question is essential since it determines how many resources we must use to sort out our data before we have to make the decisions based on the delivered reports. A company must know the quality of its data and either leave it with it or to do something about it. Unfortunately, we often experience that data quality is known as being poor and the data warehouse is thereby unused. That is unfortunate waste of resources. For tasks that create extent required quantitative analytical competencies, a business performance specification will take the form of ongoing dialogue of quantitative analytical tasks. Naturally, this means that unforeseen problems might be encountered in this process. This must be discussed and dealt with. The initial preparation of business requirements must state clearly who possess business key competencies for answering any questions, and then make sure that these people are available as needed. Similarly, in connection with major projects such as data mining solutions, certain sub-targets should be agreed on to facilitate a continuous evaluation of whether the performance of the overall task is on track in relation to its potential value.
Thank you, Ivy and Joanne, and I hope you all learned something.
Live straight from the 24 News TV station, airing for 5 minutes, bringing the latest and reliable news updates to your homes.
Listen to 24 News. This has been your attested mood reporters. Joanne, Anna
Ivy Jane Dalaserna.
for the change.
For the people,
The catalyst of change.
The beholder of truth, the voice of justice. For the people, the
24 News.